Hey there guys, so probability is probably my most heavily requested topic. It's kind of the hardest one to do as well because there's so many different types of questions. So this video is potentially the start of a new probability playlist where in each video we're going to go through 5 different types of question that pop up on foundation and higher papers together. So if you like the sounds of this, give us a thumbs up, let us know down below in the comments. Okay, so for the first question, when a drawing pin is dropped, it can land point down or point up. Lucy, Mel and Tom each dropped the drawing pin a number of times and we've got their results in the table down here. Then we're told Rachel is going to drop the drawing pin once. We are asked whose results will give the best estimate for the probability that the drawing pin will land point up, and we must give a reason for our answer. So this comes down to the classic old, the more times you do something, the more reliable your results are. So we're looking here for the person that dropped the drawing pin the greatest number of times. So if we add them all up, Lucy dropped it 31 and 14 times, which is 45 times in total. Mal dropped it 53 and 27 times, which is 80. And Tom couldn't really be bothered, he only dropped it 25 times. So Mal dropped the drawing pin the greatest number of times, so her results give the best estimate for the probability. So it's Mel, because she dropped the pin the most times. Cool. Okay, and then for part B, we are told Stuart is going to drop the drawing pin twice. We want to use all the results in the table to work out the probability that the pin will land point up the first time and point down the second time. So notice how it says use all the results in the table. So what we can do using all the results in the table is work out how many times in total the pin was dropped. We can work out how many times in total it landed point down, and also how many times in total it landed point up. So let's make another column, let's call it total. So the total number of times that the pin landed point down is 31 and 53 and 16. Now that's going to give us 100. Okay, then the number of times it landed point up is 14 and 27 and 9. Now that is 50. So our total number of times the pin was dropped, and you can check this by adding up our other totals underneath the table. We should get 150. So from that we can now get two probabilities. So the probability the pin would land point down would be, well, out of the 150 times it was dropped, it landed point down 100 times. So the probability would be 100 out of 150, which simplifies to 2/3. So we're going to need that. And then the probability that it landed point up, well, it happened 50 times out of the 150. So the probability of it landing point up is 50 out of 150, which simplifies to 1/3. So now we can answer the question. So we want the probability the pin will land point up the first time and point down the second time. So when you're doing successive events like this, successive means one after the other, you multiply the probabilities together. So we want to do point up, or the probability of point up, so 1/3 times the probability of point down, so times 2/3, and that will give us 2/9. Okay, next up, so we got 6 cards here, 3 of them are labelled A, 2 are labelled B, and 1 is labelled C. 2 cards are going to be picked at random. For part A, we're assuming the first card does not get replaced. And then we want to work out the probability both cards are B. So, first of all, what's the probability of picking a B on the first go? How many B cards are there? There are 2 out of 6. So the probability on the first go is 2 out of 6. Now, we're doing the next selection straight after, so we're going to be multiplying this by another probability. So, whatever we pick for the first card, we're not then putting it back. So, there's only now going to be 5 cards to choose from. Now again, that's because when we've picked the first card, we are not putting it back. So the total number of cards goes down by 1. Now, if we already picked a B on the first selection, there were 2, so there's now only going to be 1. So we're going to be doing 2 6 times 1/5, which is 2/30 or 1/15. Cool. Okay, and then for part B, we're told that in fact the first card is replaced, and we want to know how this affects our answer to part A. So, the probability on the first selection of picking a B is still going to be 2 out of 6. This time, whatever we picked the first time gets replaced. So in fact, the probability of picking a B the second time is exactly the same as the first time. So we do 2 6 times 2 6, which is 1/3 times 1/3, which gives us 1/9. Now 1/9 is greater than 1/15. So the probability is now higher. Okay, next up, we've got a two-way table to fill in first of all. So, Emma, that's 45 rabbits. Straight away, put that down there in the total. we're told 30 of the rabbits are male. So 30 can go there. And then we know there's 15 females. Then we're told 8 of the female rabbits have short hair. So we can put 8 there, which tells us there's 7 females with long hair. 12 of the rabbits with long hair are male. So we can put 12 there, which puts 18 there. Don't forget to add up over the side. So along the top, 12 add 7 is 19. And then 18 add 8 is 26. Make sure your numbers add up correctly. So 19 add 26 is 45, and 30 add 15 along the bottom is also 45. Cool. Okay, then for part B, one of our rabbits is chosen at random. We want to write down the probability that the rabbit is a female with short hair. So we know the bottom of the fraction is going to be 45, because that's how many rabbits there are. Then we want the ones with short hair that are female, so that's that guy there. So it's 8 45ths. Okay, next up we got some ratio fun. So we've got red, yellow and orange. Count the buttons in a jar. The ratio of red to yellow to orange is 7 to 4 to 9. So let's write that down. Okay, now the question asks us what percentage of the buttons are orange. So we don't know how many buttons are in the jar, but that doesn't matter. We know the ratio. So what we can do is think of the smallest possible number of buttons in the jar. To get that, we add the parts of the ratio. So this ratio is telling us if there are 7 red, there are 4 yellow and 9 orange. So 7 plus 4 plus 9 gives us 20. So what that tells us, it doesn't tell us that there are 20 buttons in the jar, but it does tell us it's a multiple of 20. So say that we had 40 buttons in the jar. To find the number of each button, we would simply multiply by 2. If we had 60 buttons in the jar, we'd multiply each part of the ratio by 3. So it doesn't matter how many buttons are in the jar, we don't care about that. What we do care is first of all about what fraction of them are orange. So the orange part of the ratio is 9, so orange buttons make up 9 20ths of all the buttons. Now that's not a percentage. Now remember, percentage means per 100. At the moment, we got 9 per 20. So what would be really nice here is if we could turn the bottom of the fraction into 100, which we can do quite nicely by multiplying by 5. Now we gotta do that to the top as well. So we get 45 over 100, which gives us 45%. Good times. Okay, last one then for this video. If you want more videos like this, be sure to let me know. So, this time we got to fill in a frequency tree, first of all. So, 200 people live in a village. 23 people do not have a garden. So straight away we can put 23 in there, which means the people that do have a garden are 200 minus 23, which is 177. Okay, then we're told 10 males do not have a garden. So we're 10 in there. Now we know there are 23 people altogether that do not have a garden. So there are 13 females that don't have a garden. And we're told there are 95 males overall. So up here we've got 10 males. There are 95 altogether, so there has to be 85 of them down here that do have a garden. Now we know down here there are 177 people, so to work out the number of females we do 177 minus 85, 92. So there are 92 females that do have a garden. A nice way to check these numbers are right is to add all four of them together, 10, 13, 85 and 92, and make sure you get 200. Okay, then for part B, we are told one of the people that does not have a garden is chosen at random. Write down the probability that they are female. So, be very careful here, it's one of the people that does not have a garden. So, we are only interested in these guys up here. So, there are 13 females that do not have a garden and 23 people in total that do not have a garden. So, if we pick one of those people out of the 23, the probability they are female is 13 out of 23. Good times. Okay guys, hope this has helped. If you want more of them, let me know. Higher people, if you want more higher specific ones, let me know. I'll make it happen. Take care guys.